Today's video will discuss Chapter 8.2, using the distributive property. So what we're going to do today is actually go backwards, essentially, on this distributive property. And so instead of, we're used to having a number on the outside and distributing it to two numbers on the inside, we're actually going to try to figure out what these two numbers have in common. And then we are going to end up putting that on the outside, and essentially the answer that we have will look like what you've been using as the distributive property. So we're looking for what do these have in common. And so starting with the numbers 27 and 18, I'm looking for the greatest common factor. Okay, and the greatest common factor of these two, well, they have a 3 in common, they have another 3 in common. So if you wanted to, you could actually draw the factor trees, and you would find that they have a 9 in common, and then this has 2 y's and this has 1 y, so in common they have 1 y. So the greatest common factor is what's going on the outside. And now what I need to do is divide this by 9y. And when I divide this by 9y, I end up with 3y, right? Divide the numbers, subtract the exponents. And then over here, I'm going to divide this by 9y. The y's will cancel out. I'm left with positive 2. Now, the way that you check your answer, okay, and this would be my final answer, so I'll circle this. The way that you check your answer is you take this and distribute here, and take this and distribute here, and then this becomes 27y squared, which should equal that. And then this is 18y, which should equal that. As long as after you distribute it gets back up to the beginning, then you know that you've solved it correctly. So when looking for the greatest common factor, that's going on the outside, and then what's left would be inside the parentheses. So that's one type of problem that you might see. Another one here is going to involve 3 numbers. So if you're looking at this now, I got to figure out what is the greatest common factor of all of these, right? So it's got to be in each of these 3 terms. So I got 1 term, 2 terms, and 3 terms. So together, they don't have any numbers in common. So the only number they have in common is a 1. So I just have to write that, but I'll know that there's a 1. This has 2 u's, this has 1 u, and this has 1 u. So together they have 1 u in common. 2 t's, 2 t's, and 1 t, so together they have 1 t in common. So the greatest common factor is ut, that's going on the outside. So now I'm going to divide each of these by ut, and this becomes 7 u t squared, 7 ut, sorry about that. So I'm subtracting the exponents, dividing this by ut, and this is positive 21 t. Notice the u's will cancel themselves out. And then when I divide this by ut divided by ut is 1, so this is negative 1, right? Because there's a negative there. And so my answer would be there. And again, to check your answer, all you would need to do is take this ut, distribute, and I should get back up to the blue problem that I started with. If after I distribute I don't get back up to the blue, it means I obviously must have done something wrong. So that's how you're finding the greatest common factor in 3 terms or in 2 terms. Now let's talk about what happens when you have 4 terms. So in a problem like this one, what I need to do is figure out what do they have in common. And so I basically need to group 2 terms. So what I'm going to end up doing is grouping these first 2 and grouping the second 2. And so this is going to become 4pr plus 8r plus 3p plus 6, right? So I just grouped the first 2 and grouped the second 2. All right, kind of held the pen there. So now in common, these have a 4r in common. And so now this becomes p plus 2. Okay, and then I'll switch colors. Over here, these 2 have a 3 in common. It's a positive 3, so this is plus 3. And then this is p plus 2. Now, a lot of people make the mistake of ending here. However, now I want to think of this as a number, right? So this red is a number and this blue is a number. And in common, this red number and this blue number actually have this as a common factor. Right? So they both have a p plus 2 in common, which means that then the remainder is that and that, right? What's outside the parentheses. And so then that would be 4r plus 3. Now, if you remember in the last section we talked about FOIL, so to check your answer, you could use FOIL, and what you'll see is that you end up getting yourself back up to the top again. Okay, so my final answer is P plus 2 in parentheses times 4R plus 3 in parentheses. Okay, so that's one way to solve it. Now keep in mind, this is when they were all addition signs. I want to talk about what happens when there are negative signs. So before we do that, I want to show you kind of a math trick that we often use to solve these problems. And so you'll notice that these two quantities seem similar, but obviously aren't identical. This one is x minus 4, whereas this one's 4 minus x. So unless x equals 4, if you were to say, let's say x is 7, you'll notice that 7 minus 4 is 3, whereas 4 minus 7 is negative 3. So these are not necessarily equal. Now, if I were to multiply a negative 1 times this, remember that means I'm now going to distribute. Okay, and so this is now going to become negative 4 plus x. Right? And then if I rewrite this, because the commutative property allows me to rewrite it, I could write this as x minus 4. So you'll notice that by multiplying a negative 1, I essentially was able to flip this to make it look like that. Now they won't be identical because I still would have to have the negative 1 on the outside. So this would be negative 1 times x minus 4 equals 4 minus x. Right, so it's not x minus 4 equals 4 minus x. It's negative 1 times x minus 4 equals 4 minus x. So I'm going to use this trick of multiplying a negative 1 whenever it is that I want to flip these around. Now, coming back to the other problem, in this problem it wouldn't have mattered because these were addition signs. I'm allowed to flip things around because the commutative property allows me to move around addition whenever I want to. But when it comes to subtraction, like we said, if this were a 7, 7 minus 4 is not the same as 4 minus 7. I can't just flip the order of the numbers.
Ms. Rosalind Grant, please report to the office.
Now, using that trick, let's try to solve this problem. So what I'm going to do is group these first two together.
Brown, please report to the office.
2mk minus 12m plus 42 minus 7k. In common, these have a 2m, which means that this is going to be k minus 6. But then over here, these have a 7 in common, so I've got plus 7 times 6 minus k. Right, because I'm dividing 2m to get to here, I'm dividing 7 to get to there. Now, the question is, how can I get these two to look the same? So what I'm going to end up doing is using this trick. Right, I'm going to multiply negative 1 to that second one, I'm going to be able to flip it, so that really I'm going to multiply negative 1 to this so I can flip it and turn it into that. So I'm going to leave this first part the same. But then I'm going to take the 7, I'm going to multiply negative 1 times 6 minus k, and that will flip this around to make it k minus 6. Right? So this is negative k. When I distribute, this becomes negative k, and this becomes positive 6. Okay, and then what I need to do is obviously combine these numbers, so this is going to become 2m times k minus 6 minus 7, right? Negative 1 times 7 is minus 7, and then k minus 6. Now people ask, well, why did you do that? I did that because I want these two numbers, this side and this side, to have something in common, whereas when I was up here at this red stage, this and this looked similar, but they weren't identical. Now, using my trick, I've now got k minus 6 in common. So I now know that they have in common a k minus 6. And then what's left is 2m minus 7. Right? And so I'm allowed to use that trick as long as you'll notice that this and this do not say the same thing. So to get from this, to get from this red to this red, I had to use this blue step, which makes it so that these are not identical, right? This is plus 7, 6 minus k. This is minus 7, k minus 6. All right. Now let's talk about a couple of equations. And I know I'm throwing a lot at you, but so these are the last two problems we're going to go over. So the idea here is that this times this equals 0. And so one way I could solve this is using FOIL, but you wouldn't necessarily know how to solve that if we did FOIL. But what I do know is that in order for a multiplication problem to equal 0, one of those two numbers has to be 0. right? Both of them can be 0, but at least one of them has to be 0. So for this to be true, either 2d plus 6 would have to equal 0, or 3d minus 15 would have to equal 0. But one of these two has to be 0, because if this equals 4 and this equals 1, it won't be 0, it'll be 4, right? 4 times 1 is 4. So this would have to be 0, this number, or this number. So think of those as a number. And then all I'm doing here is just going to solve this. Keep in mind that I'm going to end up getting two different answers. That will cancel out. I've got 2d equals negative 6, which means d equals negative 3. And over here I'm going to add 15 to both sides. That will cancel out. I got 3d equals 15, which means after I divide by 3, d equals 5. So my answer, remember this is a fancy parentheses because it's a set of numbers, is either 3 or 5. And what you'll see is that when you substitute negative 3 in here and negative 3 in there, you'll end up getting 0. And when you substitute 5 in here and 5 in there, you'll end up getting 0. Those are the only two numbers that will make this statement true. Okay, so again, I'm looking for these two answers, and you'll notice that there are two answers that make this true. And then the second way that you might see a problem like this written is like this. Okay, and so again, the idea is I want it to equal 0. So I'm going to go c squared minus 3c equals 0, because I can figure out if I can turn this into a multiplication problem what this will be. I know that these two have something in common. They both have a c in common, and then this becomes c minus 3 equals 0. So I now have a multiplication problem. C times c minus 3 equals 0, which means that either this number or this number would have to be 0 for this statement to be true. So I can either go c equals 0 or c minus 3 equals 0. Well, this one's easy to solve. It's already solved for me. And then this side is not going to be too bad either. I'm going to add 3 to both sides, and I get c equals 3. So my answer here, remember it's a fancy set of parentheses because it's a set of numbers, is 0 and 3 are the only two numbers that will make this statement true. And if you put a 0 in for c, this statement is true. If you put a 3 in for c, the statement is true. Any other number will not make this statement true. All right, I know I threw a lot at you there in this video. We are going to work on this for a couple of days here in class. So thank you for watching the video. Please try the problems on the bottom of the page, and I'll see you in class.